Hello everyone, welcome to my channel. So today we are going to do Leetcode line 75, one of the question, maximum subarray. So let us first take this question, then constraint, then finally intuition and coding, and then time complexity and space complexity for the same. So let us go ahead with the same. So here, given an integer array nums, find the subarray with largest sum and return its sum. So basically, whatever input is given to us, it is having some negative numbers as well, as we can see in this particular example, right? So some negative numbers are there and some positive numbers are there. So because of that only see, the thing was like, if negative numbers wouldn't be there, right? So we could have sorted them, and then at the end, whatever sub array would be there, or even the array itself as a whole, can be said as the largest sum, and we can return that sum. But here the modification is that there are some numbers which are negative as well. So that's why in this whole array we are required to figure out with that sub array which has the largest sum, and we are required to return that sum. So that's the whole question. So now let us first check for the first example, but before that let us take the constraint. So constraint says that the length is up to 10 raised to power 5. So that's why n square solution won't work, but n log n solution would work easily, or order of n solution. And the numbers are negative and they could go up to 10 raised to power 4, means minus 10 raised to power 4 to 10 raised to power 4. So that is the thing. Now they have given us a follow-up that if you have figured out the order of n solution, try coding another solution using divide and conquer approach, which is more subtle. So now let us go ahead with first about means let us first check means let us get this question from this example. Then we will be going ahead with the intuition for the same. So now here in this example, we are given with -2 and 1 and then -3. So till now, what would be the sum? Here the sum would be -2 and 1, it would be -1, then -3 wanna be -4, and then 4 which is there, when we add up the same, then it will be 0. So till now, the sum is 0. Then if we add up this -1, then sum would be -1. Then when we add up this +2, so it would be 1. When we add this 1, then it would be 2. When we add up this -5, the sum would be -3. And when we add up this 4, so sum would be 1. So in total, the sum of this whole array would be 1. But now, while doing all this, what we analyzed that there is one portion where the sum becomes greater. So here, if we start from this positive number 4 and go up till this one, as they have mentioned here. So the largest sum here would be 6, right? If we choose this particular window, then what would be sum? -1, 1, 0, then 2 means -5 and 4 would be 1, and 2 that would be 3, right? So like this only, here the thing is that we are required to check that at which particular window we are getting the sum, which is the largest of all the windows which we had chosen so far. So that's the thing here. But this question is not just about choosing the windows, but about checking that at which point we can check that if that number itself, or by adding up all the numbers which were there, if that is also making the sum the greatest one, then we are required to choose that particular subarray. So that's the thing. Please, now let me show you that how we can code for the same. But before coding, we are required to check that in actual how we are required to code. Means, see, the thing here is that -2, 1 means if we go ahead one by one and even check that if the present number which is there, it is greater or the sum so far was greater. That if we check, then we will be easily able to figure out the candidate for our subarray for the next largest which we can form. Means basically here -2 that was starting. Okay. And then when we add up this one, right? So now the sum becomes -1. But if we check the sum and the number which is there itself, which one is greater? Greater one is 1, right? So the maximum sum so far would be the current element itself. So that's the thing. Now, next what we will be doing is, now our maximum sum is this, right? So now we will be adding up this particular element and we will be checking that while adding up this element, is this particular sum the maximum sum or the element itself was the maximum? So if we check for the both, then surely we can see that when we add up, that is maximum rather than the number itself. So like this only, then we will be moving ahead for this 4. Now for this 4, we can check that which is greater. Means when we add up to this minus 2 plus 4, that will be minus 2. And the element itself is 4. So which one is greater? Greater one is the 4, right? So that's why we will be choosing our maximum sum as 4. So now our maximum sum so far is basically equals to 4. Now when we add up this minus 1 to the same, right? So now our maximum sum becomes 3, right? And the element itself is minus 1, right? So which one is greater? This one, right? So we will be choosing this, means now our maximum sum would be 3. So that's the thing. And then we come to this particular 2. Now comes the part that which one is greater. When we add up 2 to the same, which becomes 5, or the number itself. So answer is 5. Then when we add up this one, that or the number itself. So answer is 6. And then when we move ahead, now minus 5 is there. So 6 minus 5 is greater or minus 5 is greater. So this one would be 6 minus 5. And even the maximum sum so far was 6. This one is greater. And 6 minus 5 would be 1. Right? And the number itself is minus 1. So which one is greater? This one. Right? But 6 was the maximum number so far. So that's why out of them, this will be our answer till now. And then when we add a 4, we add a 4 to the sum which was being there, mean this one plus 4, right? It becomes 5. And here it was 4, right? So which one is greater? 5 is greater, right? So that's why our temporary maximum sum would be 5. But out of all of them, the greatest is 6, right? So that's why this would be our final answer. So to be precise, what I'm trying to do is at every step, I am checking that is current element preferable to be taken to our subarray or the sum so far is more preferable to be taken. So that's the thing which we are doing here. Means basically here only we are dividing this problem into two parts, that the sum so far and even the current element, and the sum so far plus the current element. So these are the three parts in which we are dividing this particular input. And that's what we are trying to do at every step. We are checking, because see, that third thing came into picture at this particular point. Because see, if we got this 6 till this point, right? So if we would have added this 6 minus 5 and then this 4, right? So it would have been 6 minus 1 equals to 5. This was not the greatest sum so far. So that's why we were required to get only this particular subarray rather than adding these two also to our sum. So that's why we are required to divide this particular input into three parts. That is, first part would be sum so far, second part would be sum plus current element which is there, and the third part would be the current element only. So these are the three parts in which we are required to divide this input. And according to that only, we will be moving ahead and checking for that what is the largest sum obtained so far. So now let us go ahead for the coding part of the same. There you will come to know more about the same, that how we are required to implement this particular into the code. But because of these three pointers, I hope you would be able to understand that how we will be now actually going to code the solution. So now let us go ahead with the code. So here, basically this code is part of the Kadane's algorithm. So now let us first check that how we are required to do this. So now the thing would be that here, if nux.size equal to 0, then we will be returning 0. That simply means that if there is nothing in that array, right? Excuse me. If there is nothing in that array, that simply means that is sum equals to 0. And that's why we will be returning that 0 as it is. So that's the first one. Now let us go ahead. So sum max equals to num0 and sum including current equals to num0. So these are those two parts which I was saying. Sum max, that is sum so far, this is the maximum, and sum including current element, that is if we are required to include this element or we are not required to include this element. So that's the thing which we are doing at this point. Now we will be traversing our whole array and checking for each element that after including that or not including that means when our sum is at the max point. So here, our current element would be the element which we will be having at that particular index, and then sum including current would be, we will be at this point only checking that if sum including the current means presently the sum including the current would be having the sum so far plus the current element if we add that up. So that would be the thing here, and or the current element itself is maximum means the current element which was there if by itself is greater than the sum which is being there so far means the thing is that at this point if the current element was being chosen not by including into the same but individually, then the current element is basically greater than a sum so far means sum so far would be having some negative values, that's why its sum become lesser. So that's the thing. And then this will be storing some maximum sum so far. So it would be by some maximum and some including current element. So that's the thing here. And then at the end, we will be returning the maximum sum which we have obtained so far. Basically, our ultimate answer would be returned at the end like this. So now here comes the part that what will be the time complexity and the space complexity for the same. So here, the time complexity would be order of n, which we can clearly see because of this part, right? And the space complexity is order of 1 because here you can clearly see we are not using any extra space. So that's the scenario here. So yeah, this was all for this particular question. If you have any doubt about the same, you can comment that down with the timestamp as well. I'll explain you in the comment itself. So yeah, and if you like the explanation, please do like and subscribe to my channel and also do share among your friends. So this was all. Thank you.